Well, Huygens himself says Campani telescopes are better, especially the objectives, and that's what it's all about. I've been involved in testing some of the Campani lenses. Probably the best telescope of the 17th century is a 34-foot telescope, well, objective, made by Campani. There's one in the Paris Observatory, which is the one that Cassini used, that still exists. And a twin of it in a complete telescope was given to the Grand Duke of the Medici, and that's still available in Florence. The French say that the peak-to-valley deviation from the spherical of that lens in Paris is 1/4 of a wavelength. In some of the lenses, Campani lenses in Florence, it is a 1/7 of a wavelength. And that means basically that the curvature is perfect. Spherical curvature is perfect. And you can't do better than that until about the 20th century. Those are very, very close tolerances. And the only thing that you can say about that is the glass is optically not as good as ours, although not nearly as bad as you read in the books. It's got little bubbles in it, so big deal. They're terrific telescopes. I mean, I don't think that we, with just the tools that were available before we get computer grinding stuff like that, that with the regular tools we couldn't do better today. So they're very good telescopes, and in that sense, they're clearly better than Huygens' telescopes. The lenses with long focal lengths are hideously difficult to test, but the ones that are a little shorter, like the lens, the objective of the telescope that Huygens discovered the satellite with, it's got a terrible problem with overcorrection at the edges. Okay? The lens is in Utrecht, and they've done interference tests with them, and you can see the pattern. Now, that museum also has a Campani lens of the same size. By the way, it's probably made about 7 or 8 years later. But anyway, we can put the two lenses next to each other, and we can do the interference tests, and you can see that in a useful aperture of about 3.5 centimeters, the Campani lens is perfect, the Huygens lens it's got a problem. But yet he discovered a satellite with it. So we can begin to tell now some objective things about the quality of these instruments.
Well, I'd like once again to thank Dr. Van Helden for his talk.
Thank you.
And before you all leave, I'd like to say a couple of things. First, we do have a reception afterwards where you can sit and chat, and there's some food and drink. It's just go out the doors, go to your left, go walk across the big voting map of the United States, and there'll be people to direct you to the reception suite, which is just past that on the right. The other thing I'd like to say is don't forget to go out and see the total eclipse of the moon, which is also tonight. We really arrange all the astronomy things at the same time. Don't forget the total part of the eclipse begins at 9:14. By about 10:23, the moon is completely in the umbra. By 11:45, it's on its way out, and by 1 o'clock in the morning, you're either asleep or the eclipse is over. So that's fine. And then, of course, stay tuned for all of the wonderful images from the Cassini spacecraft. It's interesting. The main spacecraft is named after Cassini, and the little probe is Huygens. So in any event, thank you all for coming. Stay tuned for future events at the Dibner lecture and for this lecture which will be published. Thanks for coming again, and we'll see you next year. Not sooner.